Happy viewers. Myself, Dr. J. Abdul Bari, working as Associate Professor in the Department of Civil Engineering of K.S.Rangasamy College of Technology. In this video, I am going to present an overview of structural beam analysis, which is a very important topic in strength of materials. This topic helps us to understand how beams behave under different loadings and how internal forces like shear force and bending moments are developed. I will explain briefly the beam behavior, types of beams, types of loads, shear force and bending moment diagrams, and the point of contraflexion. The main objective of the presentation is to understand the fundamental principles of beam behavior, loading, and stress distributions. We will discuss the types of beams, types of loads, shear force and bending moment, shear force diagram and bending moment diagram, and point of contraflexion. These concepts form the foundations for the structural designs and analysis. Now let me see introduction to beams. A beam is a structural element that primarily resists loads applied perpendicular to its longitudinal axis. In practice, beams are used to carry transverse loads such as floor loads, wall loads, or moving loads. Beams are generally long compared to the cross-sectional dimensions. When the loads acting on the beam, they produce shear force and bending moments. These internal forces result in stresses, strains, and deflections in the beams. Understanding these effects is essential to ensure the safety and serviceability of the structures. Types of beams. Based on the support conditions, beams are classified into several types. First one is simply supported beam. It's supported at both the ends and free to rotate. This is commonly used in buildings and bridges. Cantilever beam. It is fixed at one end and free at other end. Examples include the balconies and the projecting slabs. Continuous beam. A beam extending over more than two supports, it's called the continuous beams. It provides better load distributions. And fixed beams. Fixed beams are those the beam's ends are fixed, preventing the rotations. This results in lower deflections but higher internal stresses. Each beam types behaves differently under the different loading conditions. Statically determinate beams. According to equilibrium conditions, beams are classified as statically determinate and indeterminate structures. So statically determinate beams are those that can be analyzed using equilibrium equations alone. The equilibrium conditions are summation of force along x direction is 0, summation of force along y direction is 0, and summation of moment is equal to 0. These beams may be subjected to point loads, uniformly distributed load, uniformly varying loads, and moment loads. Examples include simply supported beams and cantilever beams. The reactions and internal forces can be easily calculated in case of statically determinate beams. Next, statically indeterminate beams. When equilibrium equation alone are not sufficient, the beam is called as statically indeterminate beams. In such a cases, we need additional methods such as strain energy method, virtual workload method. Examples include fixed beams and continuous beams. These beams are more complex but provide better structural performance. Next one is types of loads. Beams are subjected to different types of loads such as point load or concentrated at single points, uniformly distributed load, which is spreads evenly along the length of the beam, uniformly varying load, that is load intensity varies along the beam, and moment load. The type of the load significantly affects the shear force and bending moment distributions. So in this figure, we can able to see the first one is the point load or concentrated load. Second figure is the uniformly distributed load where the loads are being distributed uniformly over the entire length. And third one is uniformly varying load. Here the beams has been distributed, loads has been distributed in a varying position from 0 to the maximum, and moment load, a moment has been applied over the beam surface. Shear force and bending moment. Shear force at a section is the internal force acting perpendicular to the beam axis. It resists the tendency of one part of the beam to slide over the other. Bending moment is the internal moment that causes a beam to bend or curve about the neutral axis. These two internal actions are the most important parameters in the beam analysis. Shear force diagram. Shear force at any section is the algebraic sum of all the vertical forces to the left or right of the section. A shear force diagram is a graphical representation of the shear force variations along the length of the beam. By convention, clockwise shear force is taken as positive and anti-clockwise shear force is taken as negative. Shear force diagrams helps us to identify maximum shear force which is critical for the design. Construction of shear force diagram and bending moment diagram. The steps involved are calculate the support reactions using the equilibrium equation, that is summation of force along Fx0, Fy0 and moment 0. Then second one is draw the shear force diagram by noting the sudden jumps at the point loads. Then draw the bending moment diagram showing the variations along the beams and to identify the point of control fracture where the bending moment changes its signs. So following a symmetrical procedures will avoid the mistakes. Bending moment diagram. Bending moment at a section is the algebraic sum of the moments of all the forces about the section. A bending moment diagram shows how bending moment varies along the beam length. The key takeaway is the maximum bending moment generally occurs where the shear force is zero, and bending moment diagram helps us in deciding the beam depth and reinforcements. Next, load, shear, and moment relationships. There are the direct relationship between load, shear force, and bending moment. The slope of the shear force diagram equals to the negative load intensity. The slope of the bending moment diagram equals to the shear force. These relationships helps us to construct diagrams correctly, cross-section results for the accuracies. General guidelines for construction of shear force diagram and bending moment diagram. Some important guidelines are the load, shear force diagram and bending moment diagram should be drawn one below the other. Use the same horizontal scales. Ordinates need not to be exact but should be the proportional. Labels important values very clearly and shows the sign conversions properly. Neat diagrams improve clarity and the understanding of the shear force and bending moment diagrams. Point of contrafracture. The point of contrafracture is a location where the bending moment is zero, curvature changes from sagging to hogging. This point occurs mainly in continuous and fixed beams and it is important in structural detailing. Sign conversions. According to the standard sign conventions, clockwise shear force is positive, sagging moment is positive, and hogging moment is negative. So we have to use the correct sign conversions, which is essential for accurate analysis. So the applications, these concepts are widely used in the structural design of the beams, bridge engineering, machine, and frame analysis. They form the backbone of the civil engineering designs. I hope the presentation helps us to give the clear understanding of the structural beam analysis.